I got a full night's rest last night. I'm feeling pretty good. What that means is, though, I tend to get excited and talk really fast. So, if I start going crazy, somebody start waving a hand or something, so I know to slow down. But no, it's good to see everybody. Did everybody have a good Valentine's yesterday? Did all the men remember Valentine's? That's important. I heard this since it's Valentine's was yesterday. I got a little joke for you. Why did the banana go out with the prune? Couldn't get a date. Didn't say it was a good joke. I just said it was a joke. Valentine's related. All right, yeah. No, we and my wife had a good Valentine's yesterday too. But it's good to see everybody. We're on week number 6, and we are rolling. We are getting somewhere. And last week, if you weren't here, we talked about the rock layers. Week before that was the flood, and of course, the rock layers can be explained by the global flood. And as we looked at the features of the rock layers, we saw that through observational science, the features confirm the biblical account and reject the idea of millions of years. And in order to summarize a lot of information that we've covered over the last 3 or 4 weeks, I'm going to show you this short clip from Answers and Genesis. So check this out.
When we look at geological features around the world, many of them are radically different from anything being formed today, like thick mud layers over continents, or coal seams covering entire states, or fossil graveyards, or frozen mammoths, or miles of underground cave passages, or thick ice sheets moving over continents, or craters of supervolcanoes, or canyons cut thousands of feet deep. It looks like the present is not the best way to explain the geological features of the past. The Bible, however, offers another way to explain features from the past. Noah's flood was a global judgment, a violent catastrophe upon the earth. Based on this truth revealed in God's Word, scientists are developing a series of models to explain how the flood and its aftermath could have shaped the world today. In the course of the flood, erosion washed away mountains of rock in some places, while miles of mud and sand were piled up in others. The Earth's crust was thickened in some places and thinned in others. Like jostled ice cubes sink and bob up to their proper level in the water, some sections of land sank after the flood, while other sections rose. Supervolcanoes and superquakes rocked the world after the flood. As the centuries passed, the catastrophes became rarer and smaller. Modern earthquakes and volcanoes are dim leftovers from this violent period of Earth history. Warm oceans after the flood produced violent weather, possibly even hypercanes, huge hurricanes like the Great Red Spot on Jupiter, which may have persisted for centuries. High rainfall after the flood filled enormous lakes, eroded large canyons, and carved cave systems. As animals left the ark, multiplied, and spread over the earth, many of them were preserved as fossils. Some were buried in ash and mud. Some were preserved by unique chemical conditions, and others were frozen. Truly, the present is not the way things were in the past. Instead, the Bible is the key to help us understand geological features around the world.
Yeah, the present is not the key to the past. We mentioned this last week. If there was a global flood, as the Bible describes, you expect to find billions of dead things buried in rock layers laid down by water all over the earth. And I'm repeating this phrase a lot on purpose, hoping it gets drilled into your skulls by the time we get done, because it's very, very important. And last week we talked about the rock layers. Tonight we're going to talk about the fossils in those rock layers. And kind of a setup to this whole storyline of what we're going to be talking about tonight, I have another joke for you. I know. It's another Valentine's joke, but I think it correlates fairly well. At least I'll try to make it correlate. It's a husband and wife. They woke up on Valentine's morning, and the wife looked at the husband and said, "I just had the most incredible dream that you bought me this beautiful pearl necklace for Valentine's Day. What do you think it means?" The husband looked at her and said, "Just wait till this evening." So, of course, all day she's really excited. Evening comes, husband walks in with a package. She grabs it, opens it up real quick, and it's a book. And the title is How to Interpret Dreams. Poor woman. I feel like that's the way the scientists are when they look at the fossil record. Because we talked about you don't see evidence for macroevolution today, and we don't see a mechanism for it. The only place you could find evidence for macroevolution would be in the fossil record. So they dig in, they're opening up the fossil record, hoping to find the answers they've been looking for, and then they're just not there. Now, that's not what you're going to hear in the textbooks, though, or from the secular scientists. Here's a quote from Richard Goldschmidt, a very famous evolutionist, who says, "Paleontology, the study of fossils, is thus unable to present organic evolution as visible fact." Or this quote from this textbook, "Fossils offer the most direct evidence that evolution takes place. Fossils therefore provide an actual record of Earth's history, of Earth's past life forms. Change over time, evolution, can be seen in the fossil record." And again, you have to be careful of that word evolution. We talked about on week 2 how they use it. They start off with, well, evolution means change over time. Things change over time. Then they lead you into where everything came from non-living matter. Everything comes from a common ancestor. It just leads up to that. So essentially they're saying this is true for the whole theory, molecules to man evolution. And of course, it's presented as absolute fact in our culture, in our media. Here's a quick little clip from the show Friends.
Excuse me. Evolution is not for you to buy, Phoebe. Evolution is scientific fact, like the air we breathe, like
How
gravity.
can you not believe in evolution?
I don't know, just look at this funky shirt.
Phoebes, I've studied evolution my entire adult life, okay? And I can tell you, we have collected fossils from all over the world that actually show the evolution of different species, okay? I mean, you can literally see them evolving through time.
Really? You can actually see it?
You bet. In the U.S., China, Africa, all over. Okay, Phoebe, this is it. In this briefcase, I carry actual scientific facts. A briefcase of facts, if you will. Some of these fossils are over 200 million years old.
And of course, the connotation attached to the video is if you don't believe it, you must be crazy or stupid or evil, as Richard Dawkins says. So, is this true? Well, the thing we've got to remember about the fossils is that, of course, we exist in the present. And when do fossils exist? In the present. So you remember that from week 1. Yeah, they exist in the present. If they didn't, we would not have them. And again, remember, when you find a fossil, it doesn't come with a date stamped on it or a label telling you how it was formed, when it came about, and all that kind of good stuff. And they don't talk. You have to interpret what you find. So once again, we're at the same point we've said multiple times that you have biblical scientists and secular scientists looking at the same data, but they interpret it differently based on our starting assumptions about the past. And the same is true with fossils. And what we're going to do tonight is what we did last week. We will take observational science, look at the features of the fossil record today, and see which one is actually best confirmed by the evidence, which interpretation is best confirmed by observational science. So let's talk about the fossil record. And the first thing we need to realize about the fossil record is that it is a record of death. It is a bunch of dead things. When you find a fossil in the ground, the only thing you're sure of is something died. And as we look at this fossil, this record of death, we'll see evidence of pain and suffering. There's evidence of bite marks and claw marks on these bones. We see evidence of suffering and disease, things like tumors, cancer, arthritis, and dinosaur bones, and other fossils as well. We see thorns that are supposedly hundreds of millions of years old, but the Bible says thorns came about as a result of the curse. That before Adam sinned, the world was perfect, that everything was vegetarian. And God looks down on day 6 and calls everything very good. Now, I know this is a review, but it's very important. So God looks down on day 6 and calls it very good. This makes it very clear, according to the Bible, that death came into the world after Adam's sin, not before. So the record of death, this fossil record would have to be laid down after Adam's sin. Well, what would lay down this fossil record? It's going to be the global flood. It's going to lay down the majority of the fossil record. Maybe not all of it, but a big part of it. So we'll go through some of the facts about the fossil record. The first thing you should realize is that the fossil record is 95% marine invertebrates. That it means creatures without a major backbone. 95% of the fossil record are water creatures. I wonder what type of catastrophe could cover the entire world and bury marine critters everywhere. Maybe a global flood. Yeah. Of the remaining 5%, 4.75% of that is algae and plants. Then you got insects make up a decent little portion. There's only 0.0125% left for vertebrates, and most of those are fish. Only a tiny fraction are land vertebrates, just a tiny fraction, and most of those are made up of one bone or less. There's not a whole lot to work with. Also, these marine critters are in all rock layers, even on top of mountains. We mentioned this a couple weeks ago. Miles above sea level on Mount Everest, on the Andes Mountains, and so forth. And what you'll notice about some of these marine fossils, that you notice these giant oysters and clams, you'll notice they are, of course, fossilized, but they're fossilized in the closed position. Usually when a clam dies, it opens up, muscles relax, opens up. You walk on the beach, you find half the shell, and there it is. Well, these are fossilized closed. That means what? They had to be buried quickly, suddenly. Didn't have time to die or open up. And in order to get fossils, this helps us understand you actually require very special conditions. Now, who of you, when you went to school, got the impression that it took millions of years to form fossils, or at least a really long time? I know for some of you it has been millions of years since you've been in school, but kind of close to. We get that idea, but that's really not the case. Because we all know if our pet Fluffy dies, and we put Fluffy in the backyard, and we don't bury Fluffy, Fluffy's going to decay, bacteria, scavengers are going to eat Fluffy, and Fluffy will disappear, and Fluffy will not fossilize. And I'm sorry about Fluffy, but okay, that's what happened to Fluffy. And the same thing in the water. We get this impression that, fish, when they die, they sink to the bottom. Then they're gradually covered up with sediment over tens or hundreds or thousands of years, just waiting to be fossilized. Is that really what happens? Most fish, when they die, they actually float, for one thing. That's going to be problem number one. And if you don't believe me, you can do a real simple experiment. Just go home, grab some cyanide, throw it in your fish tank, and just see what... Okay, don't do that. And kids, don't do that. There's a joke. It's a bad joke, but don't do that. Do not throw cyanide in your fish tank, but they will die. They will float. And even if they don't float, they're still going to be scavenged very, very quickly. They're going to be eaten by bacteria, scavengers, decay process. Actually, the scavengers and bacteria and the decay processes we have are very, very good. They're very efficient. And that's a good thing, or this world will be covered up with a whole lot of dead things. It's interesting. An entire well will actually disappear in 10 years and not fossilize. An entire well. So in order to fossilize something, you need very special conditions. What you would have to do is something like this. You need to sneak up on your pet fish, Nemo. So Nemo's just chilling in a fish tank, just hanging out, doesn't know what's going on. You need to grab a big old bucket of concrete without him knowing, and then dump it on him real fast. Okay? Poor Nemo, right? But if you do that really quickly, I really do like pets. I don't know, it's just kind of fun to pick on them. But no, if you bury him very quickly and you protect him away from scavengers and away from oxygen, decay, and bacteria, he will have a chance to fossilize, but he needs to be buried very, very quickly. A good evidence that things had to be buried to fossilize is actually the Titanic. There was an expedition done by Robert Ballard who went to go check out the Titanic, and the Titanic sank actually 100 years ago this year. And it's 2 miles underwater, and where it resides, it's almost freezing. Very cold temperatures. And the guy who was leading the expedition finally got a submarine that could go down there. And he had a camera on it, and he told the guy who was interviewing him that he was pretty scared when they turned the camera on because he expected to see a whole lot of dead bodies that had sunken down after, with the Titanic, and figured in the very cold conditions with not a whole lot of life there to eat the bodies, they'd be left over. It'd be a gruesome sight. So, the camera turns on, they're scanning the ocean floor, and they come across this. And he said his stomach just knotted up. He thought they found the severed head of a child. But upon a closer inspection, it was the head of a porcelain doll. They actually found no bodies. There were no bodies down there. And actually what they had saw is that there was a bacteria that had eaten the flesh of the bodies, and the bodies had basically, they were gone, they didn't fossilize. And then the ship itself was also being eaten by a certain bacteria that likes iron. The ship is breaking down. What they did find, though, all over the bottom of the ocean floor were matching pairs of shoes, left and right. Evidently, what had happened is the bacteria that ate the people didn't like something in the leather and left the shoes there. Which, I guess you can say that means the Titanic left a lot of lost souls on the bottom of the ocean. But, I'm sorry. I didn't run that by my wife either. I'm not sure. I'll hear about that later. Okay. I heard somebody say it. I kind of liked it. No, but to get a fossil, you need something very, very quick to happen. Like, to get this fossil, this guy has to be very buried very quickly. He's in the process of eating his last meal. Didn't even get to finish it, just frozen in time. And since he did not finish his last meal, we call this fossil the Last Supper. Last one. And then here's the fossil ichthyosaur giving birth, again, fossilized in the very process of giving birth. And it doesn't take millions of years to give birth. Amen, said all the ladies, right? It's a very quick process. Here's a fossilized pickle. That's right, it's a fossilized pickle. Somebody took a bite of it, it got left in some bad watery mineral conditions, it fossilized in less than 20 years. Here's a teddy bear that turned to stone in less than 4 months. Here's a bag of flour that got left behind in a mill that flooded, turned to stone in less than 100 years. Doesn't take very long. Usually has to happen very quickly. And check out this fossil right here. This one had to form very quickly as well. Okay, that's not a real fossil. Who remembers cassette tapes? Anybody? Can I get? Oh yeah. Who still got some? All right, good. Yeah, I still got some. Now I don't have any 8-tracks. Anybody got any 8-tracks? Okay. All right. Here's the point, though. In order to get fossils, you need some very special conditions. Things normally have to be buried very, very quickly. If they're not, they decompose, they rot, they go away. And evolutionists know this. Here's a quote from an evolutionist who says, fossilization is a process that can take anywhere from a few hours to millions of years. Which, just for the record, we've observed things turn to fossils in a few hours. We've never observed something fossilizing over 1 million years. That's not observational science. But anyway, if the groundwater is heavily laden with minerals in solution, the process can happen rapidly. Now, I'm willing to bet that during the conditions of the flood, there's a whole lot of groundwater. Fountains of the great deep bursting forth, flooding there. Yeah. Perfect conditions for flooding, fossilizing the animals, and also creating the rock layers fairly quickly, like concrete. This also probably explains why we see so many fresh fossils. Now, I've tried to cram a lot in tonight. Hopefully I don't run over too much. And I'm trying not to talk too fast. But there are so many of these. I get so excited. I read a new article. I want to throw in another picture and another thing. I'm just going to show you a few of these fresh fossils. Here is a salamander that, according to evolutionists, this tissue from a salamander is 18 million years old. Yet the tissue has fully intact muscle tissues, blood-filled vessels, and quote-unquote fresh meat. Now, it's hard to believe that could be 18 million years old. Or how about this? Here's a lobster shell, the original lobster shell, the actual original organic matter, still there, suggested to be millions of years old. But is lobster shell going to last that long? Or how about this? Here's a fern leaf fossilized. You can still see the green color in the fern leaf. Here's a shrimp that's supposedly hundreds of millions of years old. You can actually still see the color, and look at the detail. Had to be buried very quickly, protected from scavengers and decomposition. Also, what's interesting about this one, like many other fish fossils, when it's cracked open, they actually smell the smell of fish. That's how fresh some of these things are. And that's a common occurrence, by the way. And then what about this one? Here's a feather that still retains its reddish color. This fossil, the red color of the feather, this evolutionist says this find, like the other ones we just showed, contradicts the well-known fact that the majority of organic molecules decay in just thousands of years. None of these things should be around after thousands of years, much less millions. Here's another one just real quick, a fossil squid, supposedly 150 million years old, but the ink was fresh enough they could actually take it, dip a pen in it, and write with the ink. But they still believe it's 150 million years old. Or how about this one? T-Rex bone, supposedly 68 million years old with red blood cells. And red blood cells are mainly made up of water. Won't last past thousands of years. Fresh tissue that was still stretchy. And what I'm going to do, I want to show you a little clip from the Discovery Channel that's dealing with this very issue. And I want you to pay close attention to how the evolutionists interpret what they're looking at and what they say in response to what they find.
Scientists have now abandoned the search for DNA preserved in amber. But since then, researchers have recovered longer stretches of ancient DNA from a 40,000-year-old mammoth and 45,000-year-old Neanderthal bones. So why not from dinosaurs? The problem is that DNA is weak. As dinosaurs fossilize, bacteria, water, changes in temperature, and cosmic rays all break it down. Today, many scientists doubt that DNA can survive for more than a few million years. It appears that recreating dinosaurs will never be possible. Then, surprisingly, hopes of finding dinosaur DNA unexpectedly revive. This time, it may come directly from a dinosaur. Famed paleontologist Jack Horner was an advisor to the Jurassic Park films. He discovered the first evidence that dinosaurs cared for their young, and he has pioneered the use of groundbreaking new techniques, like this laser mapping tool. Now, he sparks another breakthrough. In 2003, in the Montana Badlands, Horner's team is excavating a remarkably well-preserved T-Rex skeleton. But the site is so remote, they can only carry it out by helicopter. And the thigh bone is too heavy. They have to break it in two.
People just don't normally go around and break their bones open. And even for us, this was a time we just broke it because it was the only way to get it out.
Horner gives a piece of the bone to his former student, paleontologist Mary Schweitzer. She examines it and immediately notices an unusual bone structure inside. It resembles a distinctive type of bone found only in pregnant birds. Puzzled, she asks her assistant Jennifer Whitmire to do something rarely done before. They place it in an acid solution to dissolve away some of the minerals on the surface. 6 hours later, Whitmire looks again.
She ran into the room. She says, "You are not going to believe this." When she picked up a small piece to stop the reaction by putting it in water, it stretched and it sproinged and it moved all over the place. So we knew we had something pretty unusual.
It appears to be soft tissue. When they look at neighboring parts of the bone, they're even more surprised.
Out popped the blood vessels, and they were pretty incredible. And I said, "I don't believe it. That's not possible. We need to do it again and again." It's one of those just goosebump-inducing scientific moments. That's all I can say. And they don't really happen very often.
Blood vessels should not exist in fossilized bone. Many scientists believe organic molecules can't last more than 100,000 years. Yet Schweitzer's bone is 68 million years old.
I think the presence of soft tissues and cells indicates there's a process going on that we didn't have a clue about. So I think it means that we have to kind of rethink the whole chemical process of making a bone turn into a fossil.
Now, Schweitzer and Horner begin searching for more soft tissue. Do bones on museum shelves around the world contain dinosaur tissue with protein and perhaps even DNA?
Okay, I got it.
At Montana State University, they look for another promising bone to sacrifice.
Set it down right here.
I just feel really bad that it took a long time and a lot of work to put this thing together. I mean, you can see all the cracks and stuff in it, but now we get to break it apart.
Their instrument of choice, a hammer and chisel.
We're just going to pull it apart.
Yep.
Are you ready? Okay, here it comes.
After treatment, these too seem to contain soft tissue. But she still needs to prove it. So she turns to a powerful electron microscope. And now, at 4,000 times magnification, she sees tiny structures preserved in such detail that they are unlikely to be mineralized fossil. They appear to be microscopic cells that build dinosaur bones.
This is an osteocyte. This is a bone-forming cell from a dinosaur. Osteocytes are really distinctive because they have these little cellular extensions that they call philopodia, which means little feet. You can actually trace these philopodia back to the cell body. You can see them split and diverge. It's pretty cool.
Schweitzer's bone seems to preserve soft tissue. It should tell us more about the biology of these ancient beasts. and it may even contain dinosaur DNA.
At this point, I think pretty much anything is possible.
Anything? I mean, like it's not 68 million years old. I don't know if you caught it, but did you notice what they said? It shouldn't be there. This bone is 68 million years old. So what she said, we got to rethink chemical processes. Somehow nature preserved this in a way we don't know about. And what's really intriguing, if you'll watch very closely, if you read a lot of the evolutionist arguments for certain things or how they try to explain stuff away, if they don't have an answer for it, this is the default response. We don't know how it happened, but nature did it somehow. Nature becomes God. Naturalism, it makes sense. And did you notice that's just a common thing you see on Discovery Channel? How many times did they say that fossil was 68 million years old or 100,000 years old? Over and over, just as absolute fact. No question about it. You see that a lot. All right, moving on. Massive fossil graveyards. We find these all over the earth. The earth is covered by three-fourths of the earth's surface is covered by these massive fossil graveyards. In some places, as much as 40,000 feet thick. And these fossils, the billions of them in some sections, almost trillions in some areas, would have to be buried very, very quickly for all of them to fossilize at the same time. And there is absolutely no mechanism in the present that is forming massive fossil graveyards like we've seen form in the past. No mechanism operating right now that does that. Ken Ham says this about the fossil graveyards: the contorted shapes of these animals preserved in the rocks, the massive numbers in them in fossil graveyards, their wide distribution, and some whole skeletons all provide convincing evidence that they were buried rapidly and testify to massive flooding. And then you got this issue. We're going to run through some of these kind of quickly because time is escaping me. The geologic time scale. The question I get a lot is, do these fossils appear in any type of absolute order? And the answer, sort of. They do appear in a order. They have a tendency to appear in an order, but it's not absolutely concrete. Here's their tendency. Now, of course, it's scattered all over the earth and broken apart, but the tendency is you get bottom sea dwellers at the bottom of the fossil record, then you get fish, and then you get amphibians, and then reptiles and mammals. So if you can just remember farm, fish, amphibians, reptiles, and mammals, that is the general tendency of the fossil record. Now, it's not perfect, and there are exceptions everywhere, but that is the tendency. And so, since that is the tendency of the fossil record, guess what evolutionists believe? That this is the order of evolution. Single-celled organism, bottom sea dwellers, fish, amphibians, reptiles, and then mammals. Here are a couple quotes. The record of evolution, like any other historical record, must be construed with preconceptions. Not the least of these is the hypothesis that evolution has occurred. And here's another very honest evolutionist, Tom Kemp, who says, a circular argument arises. Interpret the fossil record in the terms of a particular theory of evolution, inspect the interpretation, and note that it confirms the theory. Well, it would, wouldn't it? Or I like this one. Another evolutionist, a very famous evolutionist, he says this: one of the ironies of the evolution-creation debate is that creationists have accepted the mistaken notion that the fossil record shows a detailed and orderly progression. And they have gone to great lengths to accommodate this fact in their flood geology. What's he saying? Well, there is a general order, but it's not perfect. It's definitely not perfect. And then Dr. Gary Parker sums it up well. He says the geologic column is an idea, not an actual series of rocks. Nowhere do we find the complete sequence. But still, the geologic column, that is the layers with the fossils in them, does represent a tendency for fossils to be found in groups and those groups to be found in a certain vertical order. So the question is, why are they even in a tendency? Why is there a tendency for them to be found in a certain order? And I think there are 4 good answers to that. During a flood, a couple things. Number 1, as the flood waters are rising, carrying sediment with them, they're going to bury things according to where they live. So the first reason you're going to find things in a particular order is habitat. Clams live at the bottom. They get buried first. Birds can fly, they live in trees or whatever. They'll get buried last. That's the order we tend to find. Number 2, intelligence. I don't think clams are that smart. Does anybody know how to measure the IQ of a clam? It can't make a decision to run away when it sees the flood waters coming. Compare that to humans who, of course, see the waters rising. They're going to do what? Go to high ground, right? Then grab stuff that floats. They'll be buried last, and we find human fossils at the top of the record. It makes sense. Mobility is going to be an issue. Pretty sure clams don't run that well. You expect to find them at the bottom. Of course, birds have the most mobility. They're at the top. That makes sense. And then last but not least, their body density. Just like different rock particles are going to settle out in certain layers due to their density and circumference and weight, you would expect the same thing with animals as they're carried along by moving water. So if there was a global flood, what order would you expect to find things buried in? Well, in general, to where they live. So you'd expect to find bottom sea dwellers buried first, and single-celled organisms like bacteria and plankton at the very bottom. Then you would expect to find fish buried next, because they're next up in elevation. And then the amphibians who live in the shallow water, and then the reptiles who live close to the water or lower elevations. And last, you would expect to find mammals. Lo and behold, that is exactly what you find. So that explains the general tendency of the fossil record. Then you have this issue, the gap problem. And we could go on and on about this. I'm going to point out two things today, and we'll move on. There's a whole class devoted to intermediates later on. The first gap, the Cambrian explosion. Now, I'm just curious, how many of you have heard or know about the Cambrian explosion? Okay, not a lot, so I will go. Okay, I'm going to focus and go slow here. This is really, really, really important. This is a really big gap for the evolutionists. All right, here's the thing. It's called evolution's Big Bang because basically it's when all of life exploded onto the scene, according to the evolutionists. Here's the problem for the evolutionists. If you look at the geologic column right here, down towards the bottom, you'll find the two bottom layers. I'll zoom in. The second to last layer is called the Cambrian era. And according to evolutionists, that went from about 500 million years ago to 550 million years ago. Underneath the Cambrian layer is what's called the Precambrian layer. Pretty clever, I know, right? Cambrian, Precambrian. And here is the issue that we have. In the Precambrian layer, all we find are single-celled organisms like algae or bacteria or plankton. That's it. Nothing else. Single-celled organisms, which you would expect to find at the bottom of the ocean. It's normal. Then, in this Cambrian layer, we find every major animal class and phylotype, that's body type. They literally explode onto the scene in the same place in the geologic column. Every major phylotype, every major body type that exists is right there in the Cambrian layer. The problem for the evolutionists is there are absolutely no, zero, nada transitions. None. There's nothing there. And the Cambrian rock layer is the richest area for fossils. And we find no transitions. Let me point out how much of a big deal this is to the evolutionists. You see, according to the whole theory of molecules and man evolution, life came about from non-living matter. Remember, that goes against the law of biogenesis. But it came about around 3.5 billion years ago. And we find these single-cell organisms in the Precambrian layer. And then over here in the Cambrian layer, we find every major phylotype just explodes onto the scene. There are no intermediates. Do you realize that this is 75 to 80% of all of the evolution that supposedly ever took place? Let me say that again. This is 75 to 80% of all the evolution that supposedly ever took place is supposed to be right here, and there's nothing. And no one argues about there's nothing. There's just nothing. You can't dispute it. There's nothing there. And so, you've got to try to explain this away. And of course, I'll show you a couple quotes from a couple of evolutionists. Here's one who says, the Cambrian explosion is not just a case of all the major animal phyla appearing in about the same place in the geologic column. It is also a situation of no ancestors to suggest how they might have evolved. And literally, I've got 20 quotes like this. I'm going to show you two, I think. Here's another one from another evolutionist. It says, below this Cambrian layer are vast thicknesses of sediments in which the progenitors, that be the ancestors, would be expected, the transitions. But we do not find them. These older beds are almost barren of life, and the general picture, I love this, could reasonably be consistent with the idea of special creation. I think he's got a good point there. So let's look at the evidence. If Darwin was right, then what we should find is single-celled organism at the bottom, and then literally we should find 5-celled organisms, 10-celled, 50-celled, 100-celled, 1,000-celled organisms, all through this layer, and finally leading up to everything else. That's not what we find at all. We find literally every major animal type appearing out of nowhere. It's like someone spoke and they just came into existence, and then they were buried by a flood. And some evolutionists say, well, those were a lot of soft-bodied things. Maybe they just didn't preserve. And I like Dr. Gary Parker's response to this. He says, many evolutionists still cling to their general traditional belief that life did start slowly and gradually on Earth, but that the evidence rotted away since the early forms lacked hard parts to make the best fossils. Problem. Although rare, soft parts do preserve. We find fossilized jellyfish in the Precambrian layer. They're really soft. And although rare, Precambrian fossils are found. That excuse just does not work. And the problem is so bad for the evolutionists, again, many terms from the idea of panspermia, which is the idea that aliens seeded life. And some evolutionists are suggesting that maybe aliens seeded multiple forms of life, all the major phylotypes in the Cambrian layer, and that's where everything evolved onward and upward. You can do with that theory what you like. That's the idea. And then check this out. These are some of the critters in the Cambrian layer. You ever seen anything like this before? They're pretty wild. And there's a whole bunch more where that came from. They look alien, really. They look really, really, really weird. But they're in there. And here's the thing. A general rule about the fossil record is that things are getting worse over time, not better. Let me give you this quote right here. It says, decline and even extinction, not evolution, is the rule when we compare fossil sea life with the sort of marine invertebrates we find living today. In fact, all major groups, except maybe clams and snails, are represented by greater variation and more complexity as fossils than what we see today. In other words, simple translation, we're getting worse, not better. We're not evolving onward and upward to more variation and more complexity. We're actually wearing out. Second law of thermodynamics, if you remember classes way back in the day. And then you get this second gap problem, which, we're already missing 80% of evolution right there. And the second problem is there are no transitional fossils. Now, since we haven't seen it happening today, I just like throwing this up a whole bunch of times. There it is again. We don't see macro happening today. We don't see a mechanism for it. The only place you can find tangible evidence would be in the fossil record, and it's just not there. Now, we have a whole class devoted, I think week 11 or 12, to the intermediates, the suggested intermediates. There's only a handful that evolutionists will hold up and say, hey, I think these are the intermediates we're looking for. There's only a handful. But if evolution was true, you know what you would really expect to find? In the fossil record, flooded throughout the fossil record, no pun intended, billions upon billions, or even trillions upon trillions of these transitions that are obviously, clearly transitional. We don't. They find a handful and try to present those as maybe evidence, and when we get to those, we'll debunk them very, very quickly and easily. But instead of looking at the intermediates tonight, we'll get to that again in a couple weeks. Let me just throw out some quotes from a very famous evolutionist. You know him as Charles Darwin. And Darwin was actually a little bit more honest than some creationists give him credit for. He knew some of the weaknesses in his theory. Let me read you this quote from his book, Origin of Species. He says, long before the reader has arrived at this part of my work, a crowd of difficulties have occurred to him. Some of them are so serious that to this day I can hardly reflect on them without being in some degree staggered. Why, if species have descended from other species by fine graduation, do we not see everywhere innumerable transitional forms? Why then is not every geological formation and every stratum full of such intermediate links? Geology assuredly does not reveal any such finely graduated organic chain. And this perhaps is the most obvious and serious objection that can be urged against the theory. He knew it was a problem. The solution? I believe the explanation lies in the extreme imperfection of the geologic record. What's he saying? We don't have any transitions. If my theory is true, we should have millions of them. They're not there. So what's the answer? Dig more. Go dig more in the dirt, we'll find the transitions there. Well, guess what? We've been digging. Ever since Darwin, for the last 150 years, we've been digging and digging and digging. And notice this quote from David Rumpf, another famous evolutionist, who says this: 150 years after Darwin, knowledge of the fossil record has been greatly expanded. Ironically, we have even fewer examples of evolutionary transition than we did in Darwin's time. And by the way, folks, we've got over 100 million fossils throughout our museums in the world. And there are plenty more we could have, but they start throwing them away after a while because they're all the same thing. Mostly marine critters. Don't need them anymore. I got that fossil. What's interesting, this evolutionist points this out, is that even though there's no evidence for these changes, the public doesn't usually hear about this problem. It's just presented as fact. Just swallow it. So if you think about it, who's seen one of these trees of life in like a textbook or maybe on a show? Yeah, it's supposed to show how everything evolved from a common ancestor. Well, let's think about this. Science has no idea how life first originated. It goes against the law of biogenesis. The trunk is not there, the Cambrian explosion. 80% of evolution, gone. And we don't find any branches. So if you take away what doesn't really exist, what are you left with? Oh, a whole bunch of animals buried in rock layers laid down by water all over the earth that reproduce according to their kinds. Sound familiar? Absolutely. Stephen Jay Gould, a very, very famous evolutionist, says this: the extreme rarity of transitional forms in the fossil record persists as the trade secret of paleontology, the study of fossils. The evolutionary trees that adorn our textbooks have data only at the tips and the nodes of their branches. The rest is inference, however reasonable, but not the evidence of fossils. And then this one right here. In the years after Darwin, his advocates hoped to find predictable progressions. These have not been found. Yet the optimism has died hard and some pure fantasy has crept into the textbooks. Really. Matter of fact, this is taught in textbooks as well, and some scientists think, well, maybe evolution doesn't happen in small changes. Maybe it happens in jumps, called punctuated equilibrium. And this is kind of the idea that maybe the mutations build up in the DNA, and then one day, bloop, out pops something brand new. We don't have time to get into all the problems with that idea, but I think you can kind of figure them out on your own. But I love this from this textbook. It says, thinking critically. Things have evolved. But which way is the best description? Gradually, or maybe punctuated equilibrium? That's thinking critically. You're given two options and both assume evolution is true. That's like asking the question, have you stopped beating your wife yet? If you say yes, you were beating her. If you say no, you haven't stopped. Either way, it's not a good thing. All right, moving on. I kind of kicked a dead horse for a while, but that's really important. No change from past to present. What's really interesting about the fossil record is this. Either what we see in the fossil record are plants and animals that became extinct, or they're the same as those living today. That's it. If you look throughout this record, and again, starting from the top down to the bottom, down here at the bottom, according to the evolutionist time scale, this is 500 million years old, 600 million years old. But you look at all these critters, guess what they all still look like? Their ancestors today. They look exactly the same. Maybe a little difference we'll talk about here in a second. This may be my favorite, though. This blue algae is supposed to be 3.5 billion years old, right? Literally a stone's throw away, you can go to the ocean where they found this fossil and find the same algae today. Right there, within probably 100 yards. Well, if you can throw a stone 100 yards, that's pretty good, but it's really close. And then living fossils. These are fossils where scientists thought they went extinct millions of years ago, and then we find them and they're alive, thus living fossils. And there are tons of these. We don't have time to get into all of them, just a couple. This is the Wollemi pine tree that was thought to have gone extinct 120 million years ago. Then they found it alive and well, which beckons the question, how do you miss a tree? Or, I don't know. But anyway, and so they said it's like finding a living dinosaur. Okay? Or what about this guy, the coelacanth fish? This is used in textbooks, or has been, and now they choose a different relative, but similar thing, as evidence for the fish to amphibian transition. Maybe those fins turned to legs, and that's when they started to walk. And they believe that the coelacanth went extinct around 300 million years ago, until they found it in the 1930s, swimming alive and well, doing just fine. And its fins were still fins. They had not changed the legs, but it's still in your textbooks as evidence for macroevolution. This woman wrote an article about it. She said, we found our great uncle 40 million times removed. I'm just going to move on. Niles Eldredge says this. He's a very famous evolutionist. There seems to have been almost no change in any part we can compare between the living organism and its fossilized ancestor from the remote past. Another cool little thing about fossils. Oh, I need to go quick. Wow, this took longer than I thought. We don't typically find plants and animals together. Now, if a fossil layer is really millions of years old, a period of time, don't you think you'd expect to find animals and plants together? You don't typically find them. Probably because they were sorted out during the flood and then buried in different places. Or we find tons of out-of-place fossils and artifacts. But are they really out of place? Let me just give you a few examples. Here's a human skeleton found in the Miocene layer that's supposedly 20 to 50 million years old. Another skeleton in that same layer. Here's a lead ball found in rock that's supposed to be 2.8 billion years old. Here's a handbell, I guess, of sorts, or whatever it is, found in coal supposedly hundreds of millions of years old. Here's an iron pot found in coal supposedly about 200 million years old. Then you have the issue of the Malachite man, 10 fossils found in the same rock layers as dinosaurs. Now, what they did is, we talked about last week, some of these rock layers are really, really huge. They cover entire continents. So way over here in the rock layer, they're dinosaurs. You follow the rock layer way over here, and they're human fossils in the same rock layer. But they're still in the same fossil, still in the same rock layer. Then you had this hammer that was found in rock supposedly 400 million years old, or this vessel, maybe a candle holder, I don't know what it is, found in rock supposedly 600 million years old. And again, we could go on and on, but they're all over the place. Tons of exceptions to the rule. And then I thought we'd end with this just because it's kind of fun. There is one thing we do see different about the fossils in the past. They tend to be bigger, which actually makes a whole lot of sense if you think about it. God creates everything, makes it perfect, a perfect world. Man's living to be 900 years old. Maybe man got bigger himself. Animals live longer. Maybe they grow bigger as well. Reptiles never stop growing. So if a reptile lives to be 900 years old, it's probably going to get pretty big. They're living like Adam and Eve. But we do see things were bigger in the past. Here's a fossilized dragonfly with a 4-foot wingspan. Do not run into that thing. It'll take out your windshield and join you in the front seat. And definitely don't hit it when you're riding a bike. All right. Now, roaches can get pretty big today. I just made your night, right? There it is. They can get pretty big. But we find fossil roaches that are over a foot long, 18-inch roach. All right, if those things are in my house, I'm just moving. Just going to leave. Just take the house. Yeah. Or, that would be so disturbing. Or what about this? Here's a fossilized centipede they found that was 8.5 feet long. Not 8.5 inches, 8.5 feet. It could eat you. That's really scary. We find grasshoppers that are 2 feet long. You actually hump them. Spiders. Spiders get fairly big today. Who is not a spider fan? Anybody? Yeah, me neither. I don't really like spiders. I got a bad story about spiders, but that's for a different time. Here's a fossilized spider with about a 3 or 4 foot leg span. I'm pretty sure I would cry and run away. I'm not going to mess with it. Here's a fossilized rhino, over 18 feet tall. Here's a kangaroo. We found a fossilized kangaroo that was 10 feet tall. We found, here's a guinea pig, this is not a guinea pig, it's actually a wombat, but they're similar to a guinea pig. They're usually fairly small today. We have found some that are as big as a mini in the fossil record. Discovery Channel called them Radzilla, which makes sense, but they're really big critters. Crocodiles got really big a long time ago. We see that in the fossil record as well. Even beavers, over 6 feet long, maybe even 8 feet long. Salamanders, 6 feet long. Clams, I think I showed you this before, 11.5 feet wide, again in the closed position on top of a mountain. Sea turtle, that is a really big turtle found in South Dakota, which is kind of interesting to me. But anyway, sea turtle. And then this is my favorite because the great white shark is my favorite animal. This is a tooth that belongs to a critter called a megalodon. And a megalodon is probably just an ancient great white because they have the exact same structure. But the megalodon got to be about 80 feet long. You'd have to use jaws for bait to try to catch this thing, which I wouldn't suggest because it might look something like that. Might be a bad thing. All right, here's the thing. Why do we see billions of dead things buried in rock layers laid down by water all over the earth? Why do we see huge fossil graveyards, marine fossils on top of mountains miles above sea level, large amounts of biomass in the form of coal and oil? Why are there no erosion marks or soil between the rock layers? Why are there animal tracks preserved everywhere, polished straight fossils, giant fossils? Why do we see all this stuff? I got a theory about that. Here's my theory. I think about 6,000 years ago, God created everything. And around 4,400 years ago, there was a flood. And that's my theory. And that's why we see these billions of dead things buried in rock layers, laid down by water, all over the earth. And once again, when you take even observational science and you look at what we see today, it confirms the biblical history and rejects the idea of millions of years. And once again, we have the ability to stand on the Word of God and to answer the questions of our culture and be able to give an answer for the faith that we have. It's a lot of stuff. You guys did great. If you got any questions about anything, please come on up and see me, and we will close in a word of prayer. Heavenly Father, God, we thank you for tonight. Thank you for this chance to cover all this information. And Lord, I just pray more than anything that it will remind us that the fossil record, the record of death, reminds us, God, of who you are, of your love and your mercy, and also your justice. And Lord, I pray that it will remind us of the judgment of the past and also give us a reminder of the judgment that's to come in the future, and to remind us that there's a judgment for every person that ever lives. And let that spark a passion in our hearts to move our hearts and to move our feet to reach out to a lost and dying world to share the gospel. they may not enter eternal judgment but come to you. We pray in Jesus' name. Amen.